Okay, so we left off and we were working with this augmented matrix. And what we're going to do now is go ahead and put it on the calculator and see how we can use that to solve this system of four variables. You may want to pause the video and just copy down this matrix so you have reference, because when I put the calculator up, you're not going to be able to see it. So the first thing I'm going to do is turn my calculator on. And let me just move this over a little bit so you can see the screen better. Or not. Okay. And I'm going to go to second matrix. And I have a series of matrices that are preset in the calculator. They're named for me, A, B, C, D, E, F, G. I can pick any one I want. The first thing I need to do is create the matrix, which means edit it. So I'm going to go over to edit. And I'm just going to choose matrix A because it's the first one there. There may or may not be data in the matrix already, but it really doesn't matter. You could just go over it. We know that the dimensions of our matrix were 4 rows by 5 columns. So I'm going to put that in, 4 rows, enter, 5 columns, enter. Okay, and it gives me a matrix. It has all zeros in it. I need to go ahead and put the numbers that we need to put in here, and I believe they were 0, enter. Going across our first row, 1, 1. This is a bit of a pain to do on the keyboard. -2 and -3. Enter. Now I'm in my second row. 1, 2, -1, 0 and 2, 0, 2. You can fast forward this if you really don't want to watch me do this. Our third row is 2, 4, 1. Hopefully I've typed all these right because I can't really watch it at the same time. -3. Enter. -2. And finally our last row, 1. -4. -7. -1. And -19. Okay. Hopefully I have entered all of that correctly. Okay. Once I have, I'm going to go back. Now I can clear this. This matrix is stored in the calculator, so I could say second quit, and that matrix is there. If I go to second matrix and just say show me matrix A, just hit A, enter, it's going to show me the matrix that I've entered. Okay. I can clear that out. It's still stored. I'm going to go to second matrix, and what I want to do now is an operation. I want to perform some math on it. And the operation I want is the reduced row echelon form. I want it to do all that manipulation of the matrix with those simple row operations and convert it into reduced row echelon form. Now notice on the calculator there is a REF command and an RREF. We want the second one, the reduced row echelon form. I'm going to hit enter. Okay, and now I need to tell it which matrix I want to do it, because I can have multiple matrices in the calculator. So I'm just going to go back to second matrix and tell it I want to do it on matrix A. Enter. Okay, and now it has converted and done all those row operations for me. And what this means, because my variables were in the order X, Y, Z, W, okay, first row, or first column, I'm sorry, with the 1 here, that means 1x equals -1. Okay, so x equals -1, and let's see if I can write this down here. Oops, that's no good. All right, let's go back, get this back. Okay, x equals -1, y equals 2, z equals 1, and w equals 3. That would be the solution of our system. Okay. Um, just one final bit of information I need to provide. Sometimes when you do this, you get results that look like these. As you know, that when you're solving systems of equations, it's possible to have no solutions if you have parallel lines, for example. Or it's also possible to have infinitely many solutions if you have two graphs, two lines sitting one on top of the other. If you get a reduced row echelon form of a matrix that looks like this, any row, doesn't necessarily have to be the last one, okay? But what this is saying is that 0 equals 1, right? 0 times whatever variable you pick is equal to 1. Can 0 equal 1? Not usually, or ever. So that would be inconsistent, and we can't have that. There's no solution to this equation. Okay, so this would indicate, if I could find my pen, no solution. Okay. Here, we're getting an identity, right? And it could be in any of the rows also, but here it says 0 equals 0. It could say 5 equals 5. That's true no matter what value of the variable you plug in. Okay, so this would indicate infinitely many solutions. Okay, and that is it.